let's do some math for fun. Today we are going to talk about another two sets of integrals which is similar to what we done in the previous video. Now in the previous video we are talking about how to solve the integral of e power of ax plus sine of bx dx and the integral of e power of ax times cosine of bx dx using integration by parts and complex numbers. But this one is a newer version. That's because when you have more a more linear variable inside, then you need the substitute. You may need to use more time to solve. So I have another two sets of the shortcut, and it's newer because you got more variables and you can substitute. And then when you get a similar integral like this, you can just substitute all the variable that is in its similar form. Then you can solve the integral in really fast way. So in this video, I will show you guys how to find the integral of these two. How to find the integral of these two integrals using the integration shortcut that we already derived in the previous video. So in order to do that, remember what the formula for e to the power of ax times sine of bx dx is going to be equal to e power of ax over a squared plus b squared times open bracket a times sine of x minus a times sine of bx minus b times cosine of bx, and then close bracket. So that is the solution. So we need to make this become something that is only filled with in form of bx. So in order to do that, I will factorize the c out. So this one is equal to, so let me just rewrite the integral. So this integral is equal to the integral of e power of ax plus b times sine of c times x plus d over c and then dx. And then I will apply the u substitution because I want to make the sign, the inside of the sign become in form of b times x. So I will let this equal to u, because after that I will get sine of cu, right? So let u equal to x plus d over c. Now d over c is just a constant, so du is equal to dx. Then x is equal to u minus d over c, and then we substitute all of these things into this integral, which is equal to the integral of e power of a times u minus d over c plus b times sine of c u du. And then what I'm going to do is I am going to make the exponent become something in form of a power of x. So in order to do that, I will just expand the a. I will have au minus ad over c plus b, and then by using law of indices, it's just basically e power of au times e power of negative ad over c times e power of b. So I can just take the constant out of the integral. So I will have e power of negative ad over c plus b times the integral of e power of au times sine of cu du, which is equal to e power of negative ad over c plus b times, remember the shortcut before, which is equal to e power of a at au over a square plus c square times a sine of cu minus c times cosine of cu. And then we are going to undo the substitution. U is equal to x plus d over c. So this integral is equal to e power of negative a d over c plus b times e power of a times x plus d over c over a square plus c square times a times sine of c times x plus d over c minus c times cosine of c times x plus d over c. And then we expand, then I will have e power of negative a d over c plus b times e power of ax plus a d over c over a square plus c square times a times sine of cx plus d minus cosine c times cosine of cx plus d. And then what we can see is e power of negative ad over c and ad over c we can cancel out. And then combining e power of v times e power of ax, then I will get e power of ax plus b over a square plus c square times a times sine of cx plus d minus c times cosine of cx plus d. And we are done. So this is the integral of e power of ax plus b times sine of cx plus d dx. And let's jump to the integral of e power of ax plus b times cosine of cx plus d dx. Now let's solve the integral of e power of ax plus b times cosine of cx plus d dx. And as always, look on the previous integral on this, which is this one. We will factorize the c out from here, and then I will let u is equal to x plus d over c, and then differentiate both sides. Then we have du is equal to dx, then x is equal to u minus d over c. So we will just do the similar method. So this integral is going to be equal to integral of e power of a times u minus d over c plus b times cosine of cu du, which is equal to e power of au, which is equal to then this one expand, I will have au times au minus ad over c plus b. Then this integral is going to be equal to e power of negative ad over c plus b times the integral of e power of au times cosine of cu du. And then we can just directly integrate this. So this integral is going to be equal to e power of negative ad over c plus b times e power of au over a square plus c square times a cosine of cu plus c times sine of cu. and then we are just going to undo the substitution. Then I will get e power of negative ad over c plus b times e power of a times x plus d over c over a square plus c square times a times cosine of c times c times x plus d over c plus c times sine of c x plus d over c. And then expand here, I will get ax plus ad over c, and then this one and this one cancel out if we expand this one, and then if we by using of indices and so on, then the integral of this one is equal to e power of ax plus b over a square plus c square times a times cosine of cx plus d plus b times sine of cx plus d. So this is the integral for this one. And basically the only difference is the only difference compared to the previous integral, which is the bx and cx and something like that, there is no, then which is you just like filling the integral in form of ax plus b and cx plus d, and then you replace the b with c, and that's the only difference. So it's easy, this thing is also easy to remember, so you don't need to memorize all of this. You need to just need to know the difference, then you can just already memorize this whole shortcut. And as always, if you guys enjoy this video, leave a like and subscribe to my channel for more upcoming videos, and I will see you guys next time.